Alright then, let's have iterator types. Just as we do not know the precise type of vectors or strings size type member, so too we generally do not know and do not need to the precise type of an iterator. Okay, so we just use the auto keyword. Okay, instead, as with a size type, the library types that have iterators defined types named iterators and const iterators that represent actual iterator. Okay, hold up. I just want to know there was integral type, auto, and type aliases. Type aliases. What was in type alias? Type def. Okay, type alias. Alright, of course, using keyword. Alright. Instead, as with the library types that have iterators defined with name, iterator, const iterator that represent actual iterator types. Okay, a const iterator behaves like a const pointer. Like a const pointer, a const iterator may read but not write the. Okay, may not read but no. It denotes an object of the type iterator can both read and write. Okay, it can just read but not write. Okay. Okay, so this is a const iterator and a const pointer to a const, like a const pointer. An object of type iterator can both read and write. If a vector or string is const, we may use only its const iterator type. With a non-const vector or string, we can use an object of type iterator can both read and write. If a vector or string is const, we may use only the const type iterator. With a non-const vector, we can use either iterator or const token. Terminology: iterators and iterator type. The term the term iterator is used to refer to three different entities. We might mean the concept of an iterator, or we might refer to the iterator type defined by a container, or we might refer to an object as an iterator. What's important to understand, or we might refer, okay, what's important to iterator type defined by a container, concept iterator type. What's important to understand is that there is a collection of types that are related conceptually. A type is an iterator if it supports a common set of actions. Those actions let us access an element in a container and let us move from one element to another. Okay. Each container class defines a type named iterator. That iterator type supports the actions of an conceptual iterator. Okay, so concept is more important. The begin and end operator. The type returned by begin and end depends on whether the object on which they operate is const. Okay. If the object is const, the begin and end return the const iterator. If the object is not const, they return a iterator. Okay. So we have a const vector. So this const iterator, and this will be a simple iterator. So often this default behavior is not what we want. For reasons we'll explain here, it's usually best to use a const type such as const iterator when we need to read but do not write. Okay. To let us ask specifically for the const iterator type, the new standard introduced two new functions named cBegin and cEnd. Oh, nice. So we already have a const. Okay. As do the begin and end members, these members return iterators to the cBegin and cEnd. When pass the element of the container. However, regardless of whether the vector or string is const, they return a const. Okay. Combining dereference and member access. When we dereference an iterator, we get the object. That the iterator denotes, right? If that object has a class type, we may want to access a member of that object. For example, we might have a vector of strings and we might need to know whether a given element is empty. Assuming it is an iterator into this vector, we can check whether the string denotes as empty as follows. For now reason we'll cover the parentheses empty are necessary. Right. Okay, parentheses around this are necessary, because then else it will just this dot is evaluated before the any other operator. Necessary, the parentheses, these parentheses says to apply the dereference operator to it and to apply the dot operator to the result of dereferencing it. Without parentheses, okay, this would not apply. Okay. Attempts to fetch a member from empty from IT, but IT is an iterator and has no member empty. Okay. The second expression interpreted is a request to fetch empty member from the object named IT. However, it is an iterator and has no member named empty. Hence, the second expression is an error. To simplify expressions such as this one, the language defines an arrow operator. The arrow operator combines dereference and member access in a single operation. For example, assume we have a vector of strings named text that holds the data from a text file. Each element in the vector is either a sentence, or an empty string representing a paragraph break. If empty string representing an paragraph break. Okay, if we want to print the context of the first paragraph from text, we write a loop like itc begin. We write a loop that iterates through text until we encounter an element that is empty. Okay, so we go and not empty, it is not empty plus plus. Okay. We start by initializing it to denote up till the end and is not empty. Denote the first element in text. The loop continues until we process every element in text, or we find an empty element that is empty. So long as there are elements and we haven't seen an empty element, we print the current element. It is worth noting that because the loop reads but does not write to the elements in text, we use C begin and C end. Okay. Some vector operations invalidate iterators. We noted that there are implications of the fact that vectors can grow dynamically. We also noted that one such implication is that we cannot add elements to a vector inside a for range loop. Another implication is that any operation such as pushback that changes the size of a vector potentially invalidates all iterators in the vector. We'll explore how iterators become invalid in more detail. For now, it is important to realize that loops that use iterators should not add elements to the container to which the iterator refers. Right. Okay, redo first. Okay, let's finally. Okay. Exercises. Then I have 3.4.1. 3.4.1. Then I'll create what is the exercise name. 3.21. Ooh. Vector. Okay, hold up. What is redo? First exercise from 3.333. 3.33. Where is 3.33? Oh, this is okay. So write a program to print the size and contents of a vector from exercise 3.13. Okay. Write a program to print the size and content of vectors from Okay, so I think I should have 3.333. Hold up, let me go. Yeah, okay. 3 3. Redo the first exercise. So first exercise is I can open with. Okay, so I have. I think wouldn't it be just repeating things? I don't think it is necessary. Using iterators, redo the first exercise. Okay, revise the loop that printed the first paragraph in text to instead change the element in text that corresponds to the first to all uppercase after you have updated. Okay, I can do this. Okay, so I will just quickly rename 3.21.cpp to 3.22.cpp, right? 3.22. Okay. And okay, revise the loop that printed the first paragraph in text to instead change the elements in text. The first paragraph. So I can just have a string, then hash equal cc type. Std cout, std endl, std vector and string. Okay, so let's create a paragraph. Let's create a string. Let's say string para equals this. Okay, paragraph until the string is not empty. Oh, okay. So I'll go para 1. Go para 1. Let's say first paragraph. Para 2 equals second. Para 3, just have an empty string, and string para 4 equals last, right? So we'll push it for int I. Okay, I can just declare a vector of string. Let's say paravector, and paravector dot push back. So para 1, 2, 3, and then 4. Okay, then we will loop for okay, so I want to get reference to the iterator, right? For auto it equals p vec dot c. Okay, but we want to make changes, so we will be using simple begin, not c begin, and then it is not equals to p vec dot end and the iterator is not empty. Then we can just increment the iterator. I hope it works like this, right? Not empty, and then we can, okay. We'll go for I can make a reference auto C in the value of iterator. I can just make C equals to upper of C, and then we can, okay, add the strings to the vector. Then we have make all the characters to be uppercase. Then finally we go print the content. So for auto IT equals pvec equals pvec dot begin, and I can check that IT should not be equal to pvec dot end IT plus. I can simply see out the value. So it should g plus 3.22 dot CPP. Yeah, first, second. Oh no, but it, okay. So if it is empty, it just loops out, right? So it was, okay, revise the loop that printed the first paragraph, and it said change the elements in that in text that correspond to first paragraph to all uppercase after you updated text, print its content. Okay, no. Revise the loop that printed the first paragraph in text to indicate change to instead change the elements in text that correspond to the first paragraph to all uppercases after you have updated text print its content. Okay, so what it is basically saying is that only the first paragraph need to have in the first paragraph. I print the content. Test, okay. Right, so basically this first paragraph, right, then empty, and then last one. So write a program to create a vector with 10 int elements using an iterator. Assign each element a value that is twice its current value. Test your program. That is easy. Okay, so 3.23.cpp. Vector. Then we'll go simple std cout, std cin, std L, and then finally the vector itself. Okay, so then I have, what do I have? I can declare a vector, right? Vector of int, and let's say vec, and it has 10 elements and size. Okay, so write a program to create a vector with 10 int elements using Using an iterator, assign each element a value that is twice its current value. Okay, that is easy. I can just have all 20, so all will be 40. We can start a loop. It equals I dot begin. Well, it is not equals to I dot end it plus plus. Okay, so basically I have to assign it equals 2 times value of it, and then finally I print the vector. Auto it equals I dot c begin. Okay, yeah, I should have used c begin and c end here, since I'm just displaying the values. Okay, c begin. Alright, use const iterators when you just want to read the values. Okay, so here we go. It is not equals to I dot c end, then it plus plus, and we just print the value of iterator. Okay, there we go. We have 40. Now iterator arithmetic. Okay. Incrementing an iterator moves the iterator one element at a time. All the library containers have iterator that support increment. Okay. Similarly, we can use to compare two valid iterators into any library type that contains an iterator. Iterator for strings and vectors support additional operation that can move an iterator multiple elements at a time. They also support all relational operations. These operations, okay. These operations, which are often referred to as iterator arithmetic, are described here. Okay. So, integral value yields an iterator, that is here. An iterator minus an iterator backwards. Okay. So this is compound assignment for iterator addition or subtraction. Okay, iterator plus, okay, minus. Okay. Subtracting to iterator yields a number that when added to the right hand operator yields the left hand. No. Subtracting two iterators yields the number that when added to the right hand iterator yields the. Oh, okay. The iterator must denote elements in one. Iterators must denote elements in or one past the end of the same container. Okay. The relational operators. Okay, arithmetic operations on iterators. We can add or subtract an integral value and an iterator. We can add or subtract an integral value and an iterator. Doing so returns an iterator positions forward or backward that many elements. When we add or remove integral value from and an iterator, the result must denote an element in the same vector string or denote one element the end associated string. Okay. As an example, we can compute an iterator to the element nearest the middle of a vector. Oh, this is nice. Compute an element to the element closest to the middle of Vi. Begin plus size by 2. Okay. If Vi has 20 elements, then Vi size by 2 is 10. In case we'd set mid equal to Vi, begin plus 10, remembering that subscript start at 0, this element is Vi of 10, the element 10 past the first. Okay, so first plus 10. Okay, in addition to comparing two iterators for equality, we can compare vector and string iterators using the relational operators. The iterators must be valid and must denote elements in or one past the end of the same vector or string. Okay, sorry. Okay. For example, assuming it is an iterator into the same vector as mid, it can check whether it denotes an element before or after mid as follows. Okay. We can also subtract two iterators for so long as they refer to elements in or one of the end, the same vector or string. The result is the distance between the iterators. Okay. By distance we mean the amount by which we'd have to change one iterator to get the other. The result is a signed type integral named difference type. Both vectors and string define difference type. This type is signed because the subtraction might have a negative result. Okay. Using iterator arithmetic. Then you have now using a classic algorithm that uses iterator arithmetic is binary search. A binary search looks for a particular value in a sorted sequence. It operates by looking at the element closest to the middle of the sequence. If that element is one we want, we're done. Otherwise, okay, yeah. We continue our search by looking at element after the rejected one. If the middle element is larger, then we want, okay, the middle element is larger, then then the one we want, we continue by looking in the first half. We compute a new middle in the reduced range, continue to look if we find of element. Okay, we can do a binary search using iterators as here. Okay, sort less than mid, and is this. So while mid is not equals to and value of mid is not sort. Okay, will we reach end? Okay. Text must be sorted. Okay, begin and end will denote the range we're searching. Because if we have begin and end, and mid is begin plus end minus begin original midpoint by 2, because this is one of so basically, okay, so this denotes the 0th element. Okay, so begin will not denote, begin and end will denote the range we are searching. So we begin begin plus end minus begin by 2. Okay. Well, there are still elements to look at, and we haven't yet found sort. We do this. We start by defining three iterators. Begin will be the first element in the range, end will be one past element, and mid is closest to the middle. Okay, mid value is closest to the middle. Okay, we initialize these iterators to denote the entire range in a vector string named text. Okay, this is closest to the middle. It doesn't need to be middle, it just is closest to the middle. Okay. A loop first checks the range is not empty. If mid is equal to the current value of and, okay, we update and. Okay. And equals mid, begin equals mid plus 1. Okay. So we are okay, end equals mid, and okay, because since we don't know if this is exactly mid, okay, if so, it just to ignore the second half. Okay, so mid minus 1 instead of mid minus 1, since this is not exactly the end, it is closest to and, we go and equals it. Okay, so our first loop checks the range is not empty. If mid is equal to the current value of end, then we've run out of elements to search. In this case, the condition fails and we exit the while. Otherwise, mid refers to an element and we check whether we want. If we done, we exit the loop. Okay, if we still have elements to process the code inside the while, adjusts the range by moving end or begin. If the element denoted by mid is greater than sort, we know that if sort is in text, it will appear before the element denoted by mid, right? Therefore, we can ignore elements after mid. This is which we do by assigning mid to end. Okay, if value of mid is smaller than sort, the element must be in the range of elements denoted one after the mid, right? Ahead. In this case, we must adjust the range by making begin denote element just after mid. Okay. We already know that mid is not the one we want, so we can eliminate it from the range. Okay. At the end of the while loop, mid will be equal to end, or it will denote the element for which we are looking. If mid equals end, then the element was not in text. Right, simple. Okay, redo the last exercise from 3.33 using iterators. Okay, what was the last exercise? If I may look, I've read some values. Okay, read some numbers and add to vector. Okay, print the sum of adjacent elements. Oh, print the sum of first and last elements. First and last elements. So okay, so I have to do this exercise. Let's say exercise. What is this? 3.4.2. 3.4.2. 3.4.2. Then I'll create a. Okay, this is currently empty, right? Okay, so I'll create new file 3.24.cpp. अच्छा ये वो वाला सेटिंग हो रखी है. Okay, great. Yeah, okay. So I'll just go stdcl, stdcn, and setting. Okay. So now all I have to do is read some numbers and add to vectors. Okay, so I can define some values in the vector. Right. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe we'll start with 5. Okay. Right. Then what I have to do is print the sum of adjacent elements. Okay. This is easy. Sum of adjacent elements plus 1. Right. I'll just check if .it equals ifec dot begin, and while it plus 1 is not equals to ifec dot begin. Right, it plus plus. this I will be referencing adjacent elements, so I'll go right, add and display adjacent elements, right? Format, I would need to include format for that. Okay, does it specifically say that I have to write and display? It was before iterators, so right. Okay, so read a set of integers, print the sum of each pair of adjacent. Okay, we have to print and change it so that it prints the sum of first and last elements. Okay, the sum of and is right. So I'll have value of n plus 1 and then t plus 1. Okay, let's see this works. Don't forget return 0. It's a good thing that you keep it in your mind. Alright, so we have okay, so then we compile G++ 3.24 CPP. Okay, std format. Okay, is not a member. Yeah, right. G++ dash std plus C++ 23, and then we have okay, so right, it plus 1 should not be equal to it dot begin. No, end. My bad. Okay, let's compile it again. Yeah, 1 2 is 3 2 3 5 4 5 9. Okay, good. Now I want to print the sum of first and last elements. So for it equals ifec dot begin, retrieves the size. I don't want the size. Okay, while we don't reach the middle element, right? It is not equals to begin element, right? That's exactly what I did, right? Until we don't reach, we are not equal to begin plus ivec dot size by 2 until we keep on iterating ahead, and then I can format hmm 1 minus size, right? So the sum of and is okay. So first I'll take the value of iterator. Then I want iterator minus 1. Then I need the value of iterator minus what is sorry, so I want end minus, right, because we deleted from the size. So I want ivec dot end minus iterator. Okay, let's try then. What will this fetch me? And then we can just add it, but I don't think it will be the right. Okay. I'm going to be just reading these values, so it is better to use C begin here too. C end. Okay. Then we have C begin and C end and then C end, and there we go. Let's try and compile it. Value of C end minus. Okay, so we have a problem that invalid type argument unary. Oh. Okay. So I have to go IT plus IT, not IT. It has to be. I have to define. Okay, I am right. Listen, think. Okay, so current value plus the value from last. So I can go end, right? I can have a iterator. I can have an iterator. So C end minus IT. Value of C end minus IT. I think that is where the okay. So I cannot do this. Okay, see, this will C end minus IT will fetch me some value, right, which I can add to the beginning of an operator minus IT, and I can go ivec dot begin plus okay, current iterator. Okay, I can fetch auto. I'll go last equals ivec dot c end minus where the current iterator is, and then I can add this value, right? Current iterator, wherever is this? No. If I'm adding from the beginning, this is end, right? And this is where my current iterator is right now. Okay, hold up. Let us go paint. I have this. Okay, 1, 2, 3, 4, 5, and this here is end, right? So this is 0, 1, 2, 3, 4, and 5. Okay. So iterator is at here. Iterator and then we subtract iterator minus end, so 5 minus 0, I get the first iterator itself. Okay, so begin minus and I get the iterator. Okay, I want to see, let's forget about this. What iterator does it? Reference auto try equals I vec dot end, I vec dot c end minus I vec dot c begin. Okay, then I want to see out what the value of ivec dot c begin plus try. What value will it fetch? I wish to know that. Okay, so run a command. Okay, so unqualified ID before try. Okay, I feel like value of expected primary expression before try C begin. Huh. Okay. So 0. Okay. That is okay, right? No. So something I'm missing. Seeing myself. Try expected unqualified. Oh, sorry. Try iterator. Try iterator. Right. Try iterator was not declared in the scope. Right. And it prints 0. Okay. So C end minus C begin, it prints 0, which is not there, so say minus 1. Okay, 5. Plus 1. What 5? Okay, this is invalid value. Okay, minus 1. Right, so I'll get the last value like this. Right, so I can simply say that C end minus 1 fetches me the last value. Okay, no match operator for const iterator. Okay, so this thing fetches me the second value, right? This fetches me the last value. I can simply replace an iterator here, right? My current iterator here. So I can go right begin ivec minus it minus 1. Then I can fetch its value and then I can add both of these values. So spec begin I vec dot c begin plus last. So let me do clear, then and okay, so we got 1 and 5 is 2 and 4 is 3. This is not the middle element. Okay, we don't add the middle element. Say if there were 6, you get 6 and 1, 5 and 7, 3 and 4 is 7, right? Okay. Trying to fetch the value from last. Okay, you can only subtract iterators and only okay, but iterator it didn't like it did worked on end in iterator, right? -1. I can't go past, I can go no, but see, this was not defined to okay, I'll get back. C begin plus last, current iterator -1. Iterator. Okay, can't we do I should be able to declare an iterator like that, right? Smooth operator. Let's try it one more time. It gives a bunch of error. And this time it worked. Okay. Right, because I was trying to add iterators which doesn't work. Okay, so this works, and right, and you shouldn't try to add iterators. C end -I vec dot c begin, and so it goes. Okay. And I have okay. Here's the book. Now I'll do the last exercise. Okay. In the binary search program on page central, why did we write mid equals begin instead of mid equals begin plus end minus end plus 2? Okay. End minus begin. Okay. As we wait, because in doing so we can easily refer to an iterator past the end iterator. As the search continues, right? Okay, then we are on arrays. An array is a data structure that is similar to the library vector type but offers a different trade-off between performance and flexibility. Like a vector, an array is a container of unnamed object of single type we can access by position. Okay, unlike a vector, arrays have fixed sizes. We cannot add elements to an array. Because arrays have fixed size, they sometimes offer better runtime performance for specialized applications. However, that runtime advantage comes at a loss of flexibility. Okay. If you don't know exactly how many elements you need, use a vector. Exactly. Okay. Then we have defining and initializing built-in arrays. Arrays are a compound type. An array declarator has a form of AD, where A is the name being defined and D is the dimensions of the array. Okay, the dimension specifies the number of elements and must be greater than 0. The number of elements in an array is part of array's type. As a result, the dimension must be known at compile time. Okay, the number of elements in an array is part of the array's type. Okay, as a result, which means that the dimension must be constant expression. Okay. So we have unsigned count, constant expression, unsigned 42. We can set this is bad error, and this is okay if get size is constant expression, otherwise error otherwise. Okay. By default, the elements in an array are default initialized. Okay. As with variables of built-in types, a default initialized array of built-in type that is defined inside a function will have undefined values. Right. Okay, when we define an array, we must specify a type for the array. We cannot use auto to deduce the type from a list of initializers. Okay, when we define an array, we must specify a type for the array. As with vectors, arrays hold objects. There are no arrays of references. Okay. Right. Explicitly initializing an array. We can list initialize the elements in an array. When we do so, we can omit the dimension. Right. Okay. If we omit the dimension, the compiler infers it from the numbers of initializer. If he specifies the dimension, the number of initializer must not exceed the specified type. If the dimension is greater than the number of initializers, the initializers are used for the first element and remaining elements are default initialized. Are value initialized. Okay. Array too many initializers, okay, same as before of are value initialized. Okay, so all are 0 0 0 0 1 2 value initialized. What is value initialized? 3.31 page 98. Okay, let's move on to page 98. Value initialized 99 98. What is value initialized? Okay, value initialization. We can usually omit the values and supply only a size. In this case, the library creates a value initialized element for us. The library generated value is used to initialize each element in the container. Okay, the value of the element initializer depends on the type of the element stored in the vector. If vector holds element of built-in type such as int, then the element initializer has a value of 0. Okay, this is value initialization. Okay, so all are 0 if the elements are of class. Okay, nice, got it. So these are value initialized. I'm just here. Right, value initialized, that is they have value 0. Okay, character arrays are okay. I think yeah, it's about time, so we will continue here. How much more is left? I think just this. Then multi-dimensional arrays. Pointer and arrays. Okay, pointer iterators, pointer thematic. Okay, quite a bit. Subscript and pointers. We have C style character strings. Caller is responsible for size of a destination string. Okay. Interface. Okay. So I'll continue there. Let's call it a day.